Richard, let's start with Little Green Men. There was a lot of excitement recently in the Expelled movie when Ben Stein shrieked with delight and glee that Richard Dawkins doesn't believe in God, but he believes in Little Green Men, and how crazy is that? Tell us about your love affair with Little Green Men.
Let's go back in history a little bit. In America, you can't teach creationism, or indeed religion, in science classes. And so the creationists had to give up on that. They lost a court case, and they reinvented themselves as intelligent design. And one of the chief prophets of intelligent design is a man called Dembski. And he went out of his way to say that the intelligent designer, oh, of course it's not God. Oh, no, nobody would ever dream of violating the Constitution and suggesting it was God. The intelligent designer could be an alien from outer space, for all he knew. Now, of course, that's what he says to the public media, but when he's talking to parishioners in churches and so on, it's very different. It is, of course, the God of the Old and New Testaments. However, the public stance of the intelligent design people is that the intelligent designer might as well be an alien from outer space. So when Ben Stein, who was the compere of the infamous Expelled film that some of you may have heard of, asked me in interview whether I could think of any circumstances in which I could remotely think that intelligent design of life on Earth was plausible, I raised the possibility, as I thought, extending an olive branch to the intelligent design people, that maybe an alien from outer space might have designed life on this planet. That was enough for Mr. Ben Stein. Dawkins believes in little green men, but he doesn't believe in God. And this has been held against me ever since. But I do think it's an interesting possibility to discuss that there might be life on other planets elsewhere in the universe.
Well, indeed, and I think something that fascinates me is the thought of just how similar that life might be if it existed, but also perhaps how different that life might be. I'm wondering how reasonable it is to extrapolate from what we know about science on Earth and assume that those laws and principles apply or would apply elsewhere in the universe as well.
Yes. Science fiction writers are often criticized for making their life forms too similar to our own. When I was 7, I wrote a science fiction story called Bobo Goes to the Moon, and it was about a little dog.
Was it published?
Unfortunately, it wasn't published. It was about a little dog who went to the moon, and even at the age of 7, I had the sense to realize that it was too much to hope that the inhabitants of the moon would speak English. So I made them speak French instead. It is a tussle in science fiction because the human imagination is somewhat limited, and so inevitably you tend to get roughly humanoid creatures, perhaps with rather swollen heads or perhaps an extra eye in the middle of their forehead or something of that sort. But there's rather little imagination of really, really, really alien life forms. But actually, as a scientist, I think it's a very interesting question how different they might actually be. For example, all life on this planet is based upon polynucleotides, usually DNA, and sometimes its cousin, RNA. Is that a universal? If we think about life on other planets, does it have to be based on DNA? My guess to that is not. On the other hand, I do think there's got to be something like DNA. There's got to be some equivalent to a genetic molecule, maybe not even a molecule, but something equivalent to genetics, which is going to be extremely high fidelity. It's going to have a comparable high fidelity to our own computer systems. That means it'll probably be digital. It doesn't mean it'll be DNA. DNA is digital, but it'll probably be digital. Another thing that's characteristic of life on this planet is protein. And that's not an accident. Proteins have this extraordinary quality that the linear sequence of the building blocks of proteins, the amino acids, the linear sequence of amino acids along a protein molecule determines the three-dimensional shape into which a protein molecule will coil itself. Protein molecules spontaneously coil themselves into a very, very particular shape, and that particular shape is different for different linear strings of amino acids, and the linear strings of amino acids are absolutely determined by the genetic code. And what that means is that genetic code determines the three-dimensional structure of a protein molecule. And the three-dimensional structure of a protein molecule determines its enzymatic properties, determines the chemical reactions that it will catalyze, and that in turn, through the immensely complicated cascade of events in embryology, determines the body that develops in the womb or in the egg. So something like a protein molecule has, I think, got to be characteristic of life on any planet where there's life. It doesn't necessarily have to be protein, but what I would ask of a chemist would be, can you think of any other class of molecule that has that property of folding itself up into a uniquely characteristic enzyme of which there is an enormous repertoire capable of catalyzing an enormous repertoire of chemical reactions, and this is in itself to be absolutely determined by a digital code. That, I think, pretty much has to be characteristic of life elsewhere, but the details of what the bodies look like is almost certainly going to be very alien indeed.
Okay, so I think what you're saying, life elsewhere would have had to follow the same sort of principles as life here, but it could actually be quite different.
Different in detail, yes.
I think there have been speculation about perhaps ammonia being the basis of life in other parts of the universe.
That's interesting, yes. I mean, the possibility that it might not be organic at all,
yes,
say, might not be based on carbon, that's another interesting speculation. Is carbon the only element in the periodic table that's capable of forming the right kind of chains to provide a sufficiently large repertoire of specifiable chemicals? And perhaps silicon seems to be the only other possibility that's ever been suggested. Ammonia has been suggested as a possible alternative to water. One of the characteristics of life as we know it is that it's based on water. And in fact, the people who call themselves exobiologists, who scan the heavens with their spectroscopic telescopes for the possibilities of life, what they're actually scanning for is water. They can't actually scan for life. But it's sort of become a sort of rule of thumb among exobiologists that water is what you need. It doesn't prove there's life, of course, but it's a necessary condition for life. Even that might not be true. But even if that's not true, I think I'm right in saying that some sort of digital coding for some sort of specifiable phenotypes, probably via protein, is necessary.
Okay. So in some shape or form, it is possible to conceive of life elsewhere in the universe, perhaps following similar principles, but nevertheless quite different when it comes to the realization of them. So I'm kind of intrigued now, because in your books, excuse me, particularly The God Delusion, you're absolutely adamant that if there were such a thing as a God, it would absolutely have had to have evolved. It couldn't simply have always been there. It would have had to have evolved. And yet you seem to be saying now that actually it is possible to conceive that elsewhere in the universe, different scientific laws might apply. Aren't you simply taking a law that is accepted for life on Earth and trying to apply it beyond Earth and even beyond the universe?
Yeah, this is a fascinating question. The extent to which what we can speculate about elsewhere in the universe, where we have absolutely no idea what's going on, how much we can say on sort of purely logical grounds has got to be true. And I think that the point about complexity having to have evolved is not just a point of observation on this planet. It's not just a matter of observed fact that all the complexity we see on this planet has evolved by gradual degrees. I think it's a matter of logic that complex things, by their very definition, are improbable things, statistically improbable things. And statistically improbable things don't just happen. Statistically improbable things have to come about through an orderly, comprehensible process. Evolution by natural selection is, I think, the only such process, ultimately, that we know that's capable of doing that. So I wouldn't like to say that evolution by natural selection has got to be going on any planet in the universe where there is life. But something equivalent to it has got to be going on, such that simplicity builds up into complexity by a comprehensible process.